Hello, and in this video we're going to look at section 4.4, which is on basic rational functions. Here's the definition of a rational function. It's a function that's a ratio of two polynomial functions, where p of x is a polynomial function and q of x is a polynomial function, and q of x can't equal 0. So an example of a polynomial function would be something like this. F of x equals 3x over x squared plus 2. That's a polynomial function. 3x is p of x. And q of x is x squared plus 2. Now, when we do define rational functions, we're going to have to worry about where q of x equals 0. So those types of things are going to be restrictions on our domain when the denominator can equal 0, because we can't divide by 0. So second example here may be a little bit easier, or where we just have a constant 5 over x minus 2. That gives us a p of x is 5, a constant 5 value all the time, and q of x is x minus 2. It's the linear function. So in this section we're going to look at two basic functions, rational functions. These are on your worksheet for this section, so I just took those off the worksheet. This is our first function, f of x equals 1 over x. Here are our values. It's a reciprocal function, and we've done this one as well before. So we can look at the values here. We have 3 is 1/3, so right here at 3 we're up about 1/3 right here. 2 is 1/2, we're up about 1/2 here. 1 is 1, 1/2 is 2, and 1/3 is 3. So we're right about here. So, and we have negative values as well. It's down here. So our domain is what values we can go right and left here. So the values that we can't put in here, it looks like, is 0. So our domain is all real numbers except 0. So we could write it in a couple ways. We can write it as all reals minus the number 0. Or we could just write x is not equal to 0. One of those two ways. And our range now is our how high and low it goes. It looks like this goes up and down, goes down forever, and goes up to this value here, and it kind of skips over that value and keeps going up. Goes up this way. Actually, as we travel left, we should travel left. So it goes down, jumps over, goes down. So here our range is the same as our domain. We can't get a 0 value out. And it makes sense here a little bit in that the only way we're going to get 0 out of this thing is to have this being 0, and it's always 1, so it can't be 0. So we don't have 0 in our range either. Now our horizontal asymptote is the line that runs horizontally here, which it approaches. In this case, a horizontal asymptote is going to be y equals 0. Now, end behavior says as we approach infinity, or negative infinity, where does the function go? So as we approach negative infinity here, we're going this way on the graph. As we go this way on the graph to negative infinity, we get close to 0. We're approaching 0. As we go this way on the graph to positive infinity, we are also approaching 0 on the positive side. The other one, we're approaching 0 on the negative side. So that's our end behavior. As we approach infinity, it approaches the horizontal asymptote. So whatever the horizontal asymptote, it's going to approach that value. In this case, 0 for the horizontal asymptote is the end behavior. Now our vertical asymptote is the line that it approaches vertically In this case, it's going to be x equals 0. Now, the behavior here is a little bit different because we can't go to infinity. We're actually going to the value of the vertical asymptote, the x value here. So this little symbol here, after the x value here of the vertical asymptote, means which side are we approaching it on. This says we're approaching from the negative side because it's negative. That means we're going from this direction to the negative. We're traveling in a positive way, but we're coming from the negative. So this is from negative. Okay, so we're coming from the negative side. So that means we're going this way here. So we're going down forever. So this is going to be negative infinity here, going down forever. Now as we approach from the positive side, that's this side, from positive side, then that means we're traveling the other direction. We're coming this way, traveling up to positive infinity. All right, so our end behavior there is going to be positive infinity. So the difference between the end behavior here is that we go to infinity. Here the end behavior goes to the asymptote. Now that's 1 over x's graph and its properties for this value, so a rational function. Now our second one from this thing is going to be 1 over x squared. We're going to look at that domain and range. We can see here the values are going to be going in here. We're squaring it and then taking the reciprocal. Squaring it and then taking the reciprocal. So squaring that is 9, taking the reciprocal is 1/9. And you can see here what the graph looks like when we do that. Its domain is the same as the one above, so it's going to be x is not equal to 0. We don't have a 0 value here. We can go right from 0 and left from 0, but we don't have a 0 value. We can't plug 0 in here because it's undefined. Now the range is going to be f of x is going to be greater than 0 because there's no negative values here. Every time we square something we get a positive value, so there's no negative values here, and it's not going to have a 0 either because the 1 is the numerator. You can't get 0 out of it. Now your horizontal asymptote is the same. It's going to be y equals 0. So our horizontal asymptote is this y equals 0 line. We don't approach on both sides though. As we go to negative infinity here, we go to 0 on the positive side. Positive, but we get close to 0. Same thing happens here. We get close to 0. Okay, and now our vertical asymptote is going to happen at the same value as before also. So our vertical asymptote is at x equals 0. So we have the same behavior as we had before. We're looking at as we go to the negative side from the negative side. So the negative side here, we're approaching from the negative side, coming up and approaching, so that's going to be positive infinity. And then from the positive side, we're also going to go approach positive infinity. So both sides, as we approach the asymptote, go up to positive infinity on this basic curve.